Packaging and distributing your Python code can be a complex and sometimes confusing task, especially if your projects have lots of dependencies or involve components more exotic than straight Python code. However, for many cases it's very straightforward to make your code accessible to others in a standard way, and we'll see how to do that using the standard distutils module in this section. The distutils module allows you to write a simple Python script which knows how to install your Python modules into any Python installation. By convention, this script is called setup.py, and it exists at the top of your project structure. This script can then be executed to perform the actual installation. Let's see a simple example of distutils. We'll create a basic setup.py installation script for the palindrome module we wrote in the previous section. The first thing we want to do is create a directory to hold our project. Let's call this palindrome. Let's put a copy of our palindrome.py in this directory. And finally, let's create our setup.py. The first line in the file imports the functionality we need from the distutils.core module, namely the setup function. This function does all the work of installing our code, so we need to tell it about the code we're installing. We do this, of course, with the arguments we pass to the function. The first thing we tell setup is the name of this project. We've chosen palindrome in this case, but you can choose any name you like. In general, though, it's simplest to just keep the name the same as your project name. The next argument we pass to setup is the version. Again, this can be any string you want. Python doesn't rely on the version to follow any sort of rules. The next argument, PyModules, is probably the most interesting. We use this to specify the Python modules we want to install. Each entry in this list is the name of the module without the .py extension. Setup will look for a matching .py file and install it. So, in our example, we've asked setup to install palindrome.py, which of course is a file in our project. The rest of the arguments we're using here are fairly self-explanatory, and are there mostly to help people to use your module correctly and to know who to contact if they have problems. Before we start using our setup.py, we first need to create a virtual environment into which we'll install our module. In your palindrome directory, create a virtual environment called venv. When this completes, activate the new environment. On Linux or Mac OS X, source the activate script, or on Windows, call the script directly. Now that we've got our setup.py, we can use it to do a number of interesting things. The first, and perhaps most obvious thing we can do, is install our module into our virtual environment. We do this by passing the install argument to setup.py. Setup prints out a few lines to tell you about its progress. The most important line for us is where it actually copies palindrome.py into the installation folder. The site packages directory of a Python installation is where third-party packages such as ours are normally installed, so it looks like the installation worked properly. Let's verify this by running Python and seeing that our module can be imported. Note that we want to change directories before we do this, otherwise, when we import palindrome, Python will simply load the source file in our current directory. Here we use the _file attribute on the module to see where it was imported from, and we see that we're importing it from our virtual environment's site packages, which is exactly what we wanted. Don't forget to switch back to your source directory after exiting the Python REPL. Another useful feature of setup is that it can create various types of distribution formats. It will take all of the modules you specified and bundle them into packages that are easy to distribute to others. You can do this with the sdist command, which is shorthand for source distribution. If we look, we'll see that this command created a new directory, dist, which contains the newly generated distribution file. If we unzip that file, we'll see that it contains our project source code, including the setup.py. So now you can send this zip file to anyone who wants to use your code, and they can use the setup.py to install it into their system. Very convenient. Note that the sdist command can produce distributions of various types. To see the available options, you can use the --help formats option. This section really just touches on the very basics of distutils. You can find out more about how to use distutils by passing --help to setup.py. For most simple projects, however, you'll find that what we've just covered is almost all you need to know.